Okay, welcome back, guys. Welcome back to today's lesson. In today's lesson, we shall be talking about cracked section. So when we mean cracked section on reinforced concrete, cracked section, it means that there are little cracks on the beam. So for example, now we have a beam like this. So after going through some deformations, there will be some cracks at this tension place, and we all know that when there is crack, it means the concrete will not take part in it, so it means the steel will take part in it. So from experience, the American code has given us various values to use for the cracked section. So let's go to this ETABS website. Now we can see the beams. So for beams, we are to use 0.35 times the moment of inertia. So instead of us using this normal formula, BD cube by 12, BD cube by 12, we are going to use about 35% of it. So that's what the code is telling us. We should use 35% of it. While columns, we are going to use 70% of it. Then walls, for uncracked walls, we are going to use 70% of it, because a wall is almost like a column, while a cracked wall is 35% of it. So note, it has given you some notes at this particular place, and it said that we don't design wall for out of plane movement. So that's why it's telling me to give this value for the out of plane movement. So it said I should use 0.1, while I use 0.01, which I'm going to change back to 0.1. so you can see this. Then for slabs, it's telling us to use 0.25 of this. We all know slabs are not stiff, so that's why. So in the next video, we are going to be making a model of a simple structure with both cracked and uncracked section, and we'll see the difference. So thank you for watching today's video.